So, in this lecture, I will give you a proof to the Pythagorean theorem. Pythagorean theorem relates to a right triangle like this triangle. This is a triangle which has one angle that is 90 degrees. For that reason, it is a right triangle, and actually the Pythagorean theorem says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, or in mathematical notation it says that c square equals to a square plus b square. Okay, I will repeat. The square of the hypotenuse equals to the sum of the squares, of the perpendiculars. C square equals to a square plus b square. In order to prove the Pythagorean theorem, we actually built a copy of this right triangle. A copy of it is built here, and we built the copy by actually we built side B of this triangle here on the same line of side A. Then we raised a perpendicular to side B in size of A. So side A in the right triangle equals to side A in the left triangle, and side B in the right triangle equals to side B in the left triangle, and the angle between side A and side B in the right triangle is 90 degrees, and so is the angle between side A and side B in the left triangle. It is 90 degrees because A is perpendicular to B. For that reason, the angle between side A and side B is 90 degrees. So we have here two triangles that have two sides that are equal to each other. Side A in the right triangle equals to side A in the left triangle, and side B in the right triangle equals to side B in the left triangle. And also the angle between side A and side B in the right triangle equals to the angle between side A and side B in the left triangle. Both of them are 90 degrees. For that reason, the right triangle coincides to the left triangle. Okay? According to the rule side, angle, side. If you have two triangles that are equal between them in two sides, and also the angle between those two sides are equal in both triangles, then they coincide to each other. For that reason, the right triangle coincides to the left triangle. And exactly for the same reason, because of the fact that this size is C, because of the rule of corresponding sides in a coincides triangles, this side must be C, because they coincide to each other. So suppose that we label the angle between side B to side C, we label this angle as alpha, for that reason, for the reason that the two triangles are coincides to each other, the angle between side B and side C must be also alpha. And suppose that we label the angle in the right triangle between side A to side C as x, because we don't know the size of this angle. So we label it as x, but we do know that the sum of the triangles, the sum of the angles in every triangle must be 180 degrees. In every triangle in the world, the sum of its three angles must be 180 degrees. So in the right triangle, alpha plus 90 plus x equals to 180 degrees. Okay, alpha plus 90 degrees plus x equals to 180 degrees. It is true for every triangle in the world. The sum of its three angles is always 180 degrees. So, especially in this triangle, the sum of its three angles, that is to say alpha plus 90 degrees plus x, equals to 180 degrees. Now we can subtract 90 degrees from both sides of the equation, and we will get that alpha plus x equals to 90 degrees. Okay, we subtracted 90 degrees from both sides of the equation. We got alpha plus x equals to 90 degrees. Now we subtract alpha from both sides of the equation, and we will get that x equals to 90 degrees minus alpha. Okay, in this way we found the angle x. Okay, x equals to 90 degrees minus alpha. We can write here that x equals to 90 degrees minus alpha. Now if we look at the middle triangle, we have here between side C of the right triangle to side C in the left triangle, we have an angle that we don't know the size of it, so we label it as y, and we will find what size is y. We don't know what size is y, but we do know that in every straight line the sum of its angles in one side equals to 180 degrees. For example, if we look on the line, the straight line AB, the sum of its angles on the upper side must be 180 degrees. So x plus y plus alpha must be 180 degrees, and so is the sum of the angles in the bottom side must be 180 degrees. So in total, the sum of the angles in both sides is 360 degrees. Okay, so we can write that x plus y plus alpha equals to 180 degrees. As you can see here, x plus y plus alpha equals to 180 degrees. But we know that x equals to 90 minus alpha, so we can substitute x by 90 minus alpha. Ninety minus alpha okay, here we substituted x by 90 minus alpha, and in this equation we have alpha minus alpha plus alpha equals to 0. So in this way we can eliminate alpha from the equation. We can write that 90 plus y equals to 90 degrees plus y equals to 180 degrees. Okay, alpha minus alpha equals to 0, and we're left with 90 plus y equals to 180 degrees. We can subtract 90 degrees from both sides of the equation, and we will get that y equals to 90 degrees. Okay, here we substituted 90 degrees from both sides of the equation, and we got that y equals to 90 degrees. So the middle triangle is a right triangle because one of its angles is 90 degrees. So you can see here a trapeze. A trapeze is a square that has a pair of parallel sides. A is parallel to B because here we have 90 degrees and here also we have 90 degrees. So A is parallel to B, so we have here a trapeze. Okay, this is a trapeze, and now we will calculate the area of this trapeze in two ways, and then we will compare the results. Of course, they will be equal to each other, and from this equation, expression 1 equals to expression 2, we will derive the Pythagorean theorem. So we will calculate the area of this trapeze in the first way. We will call the area of the trapeze, we will name it as S. S the area is the area of this trapeze. S is equals to the sum of the parallel sides. A is parallel to B, so it is A plus B times the height of this trapeze, that is also A plus B, and we must divide all by 2. So the first way to calculate the area of this trapeze is by multiplying the sum of the parallel sides, that is A plus B, times the height of this trapeze, that is also A plus B, and we divide all by 2. Now we can calculate the area of this trapeze in a second way. The area of the trapeze equals to the sum of the area of its components. This trapeze contains 3 triangles: the right triangle, the middle triangle, and the left triangle. So we can say that the sum of the areas of the 3 triangles equals to the area of the trapeze. Okay, so that is the second way to calculate the area of this trapeze. It is the sum of the areas of the 3 triangles that the trapeze contains: the right triangle, the middle triangle, and the left triangle. So the area of the right triangle is the base of the triangle, that is A, times the height to the base, that is B, divided by 2. So the area of this triangle is A times B divided by 2. The area of the middle triangle is the base of the triangle, that is C, times the height to the base, that is also C. So it is C times C divided by 2. Okay, and the area of the left triangle is the base of the triangle, that is B, times the height to the base, that is A, divided by 2. So it is B times A divided by 2. So, and the total area of the trapeze is the area of the right trapeze plus the area of the middle, the area of the right triangle plus the area of the middle triangle plus the area of the left triangle. Okay, as you can see here, the area of the trapeze is the equals to the area of the right triangle, that is A times B divided by 2, plus the area of the middle triangle, that is C times C divided by 2, and the area of the left triangle, plus the area of the left triangle, that is B times A divided by 2. As I have already told you, expression 1 equals to expression 2 because it is the same area that we calculated in two different ways. So now we will make an equation that says that expression 1 equals to expression 2. Okay, so we will write that A plus B times A plus B divided by 2 is the first expression for the area of the trapeze, and it is equal to the second equation of that is the expression of the area of the trapeze when we calculated it in the second way. So it is A times B divided by 2 plus C times C divided by 2 plus B times A divided by 2. So, as you can see here, this equation says that expression 1, the area of the trapeze as we calculated it in the first way, equals to expression 2, the area of the same trapeze that we calculated it in the second way as a sum of the three triangles that the trapeze contains. So those two sides are equal to each other. In this equation we can multiply the two sides by 2. Then we will get that A plus B times A plus B equals to AB plus C times C plus BA. So after we multiplied the this equation by 2, we got that a plus b times a plus b equals to a times b plus c times c plus b times a, and a times b plus b times a is 2ab, and c times c is the c square. So we can write it this way. As I've already told you, a times b plus b times a is 2ab, and c times c is c square. Now we will open the brackets in the left side, the equation. So after we opened the brackets, we got that a times a is a square plus a times b is ab, b times a is ba, and b times b is b square equals to 2ab plus c square, and again a times b plus b times a is 2ab. So, as I've already told you, AB plus BA equals to 2AB equals to 2AB plus C squared. So we have in the left side 2AB, and in the right side we also have 2AB, so we can subtract 2AB from both sides of the equation, and then we will get that I will repeat again on the previous stage. A times a square plus ab plus ba is a square plus 2ab plus b square, so it is a square plus 2ab plus b square, that equals to 2ab plus c square. Then we subtracted 2ab from both sides of the equation, and we got that a square plus b square equals to c square. And this is exactly the Pythagorean theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. or c square equals to a square plus b square. Okay, so we can summarize the lecture, and we can say that we proved the Pythagorean theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, or c square equals to a square plus b square. We proved this equation by making a copy of this right triangle here, and then we found these angles, and in this way we can calculate the area of every triangle here. And then actually we have here a trapeze. We calculated the area of the trapeze in two ways. The first way is that the area of the trapeze equals to the area to the sum of its parallel sides, that is a plus b times the height divided by 2, so it is a plus b squared divided by 2. And we also calculated the area of the trapeze in the second way. It equals to the area of its components, that is to say, it is the area of this, the right triangle, plus the area of the middle triangle, plus the area of the left triangle. And we got that the area of the trapeze equals to AB plus C AB divided by 2 plus C squared divided by 2 plus AB divided by 2. And we actually expression 1 equals to expression 2 because it is the area of the same trapeze. And after we actually made an equation that says that expression 1 equals to expression 2, we got to the last result that a square plus b square equals to c square, or the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, I hope that you enjoyed from the lecture and also understood it. All the best. Thank you very much. That's all.